Hey students, this is our last Astronomy 101 discussion session, such as it is, video. By the way, sorry for the hat and the jacket. It's freezing in this room. So I'm trying to, it's much colder in here than it is even outside, so I wasn't really prepared. But anyhow, we're going to talk about the different things that people have asked questions about. There's three main things that lots of people ask questions about, and then a whole bunch of other stuff. So I'll try to talk about the things that these three things that the most people ask questions about first, which are the Drake equation, the whole idea of spontaneous generation, where life comes from, and sort of the point of SETI. But I'll start with the Drake equation. I knew there would be questions about that, and I was bugging people to send me some estimations for amount of space aliens calculations. And so I'm just going to walk through how do you do the Drake equation. This relates to questions different people ask about, like, how do we know this? How do we know whether planets are habitable? How do we know, what's involved in life, and so on and so forth? And the answer to those questions is we don't, all right? But we can make some broad estimates, and that's what the Drake equation is about. It's about trying to make some estimates and see what does that mean. All right. So for the Drake equation, if we want to talk about how many advanced civilizations are in our galaxy, by this we mean civilizations that we could detect with a radio receiver or something like that. So by advanced, these civilizations have to at least get to the point where they're broadcasting radio signals. So you're talking about like 1920s technology or higher. Okay, so what's going to be involved in this? Okay, so here's how a Drake equation calculation works. So first of all, to have life as we know it. Now, we talked last class about why life as we know it. Somebody asked, what about angels or something like that? Okay, angels don't count, okay, because they're not life as we know it. They're not something that's scientifically understood. So if angels exist, that's outside the realm of our scientific knowledge. The same thing goes for other types of creatures that people brought up in last class. So we have to stick with life as we know it, or else I could be looking, like I said last class, I could be looking for a leprechaun or an angel right here. Okay, I don't need to go look out into space. So first of all, to have life as we know it, in other words, life something like what exists on Earth, has to be on a planet going around a star. So the first thing you have to do is say, well, stars. How many stars are in our galaxy? Because every star represents a possibility of a place you could have a planet and therefore could have a world and could have a civilization. Okay, well, there's rough estimates. There's at least 100 billion stars in our galaxy. There's probably a lot more. Why? How do you figure this out? Well, you look at other galaxies, okay, and you look at how bright they are compared to the brightness of a star. And if a galaxy is 100 billion times brighter than a star, then, ballpark figure, the galaxy must have 100 billion stars in it. Okay, so I'm going to start for our galaxy with 400 billion. Okay, so that's a good ballpark figure, is to say there's 400 billion stars in our galaxy. Okay, it might be 300, it might be 500, but that's a ballpark figure. Now, the next question is, well, okay, but we don't need stars to have intelligent civilizations. We need to have planets. So how many stars have planets? We know from our searches with like the Kepler satellite and stuff, we know that a lot of stars do have planets. There are also a lot of stars that probably don't have planets, okay? Places where there's like two stars orbiting each other, really hard to have planets orbiting one of those stars if the two stars are orbiting each other. The gravitational pull of the second star really messes things up. I know in Star Wars, Luke Skywalker is on a planet, Tatooine is on a planet that has two suns, but that's actually really hard to make work from a physical standpoint. So stars that are double stars and things like that probably don't have planets. There's also lots of stars that are really kind of in close proximity to each other. They probably don't have planets either. So, but ballpark figure, let's say half have planets. So that would be 1/2 times 400 billion is, of course, 200 billion. Okay, so you have 200, so we get ballpark figure 200 billion stars with planets. Now the question is how many are Earth-like? Now this is where we don't know. Okay, this becomes difficult. So I asked for student opinions on like what do you think would be reasonable? Okay, so I didn't get a lot of responses. I'm going to pick, but I got one I thought was particularly interesting. All right, Reese in the Southwest class sent me some numbers, and he said, okay, he said I'm going to guess. So this is the Reese criteria. He says, I'm going to guess that 1 in 10,000 stars that have planets actually have an Earth. Okay, that's not an unreasonable guess. Okay, it's perhaps a little pessimistic, but the Kepler satellite has found only a handful of candidates of possible Earths among all the thousands of planets it's discovered. So this is, and so to actual Earth, this isn't maybe a ridiculous figure. So if we have 1 in 10,000 stars that have planets actually have an Earth, then that's 1 in 10,000 times 200 billion. Okay, so billion, that's 200 million. 200 billion. So, you cancel out your zeros. So 3 zeros here, 3 zeros here, a 0, a 0. And I have now 2, 0, 0, 0, 0, 0, 0, 0. 20 million. All right. 20 million Earth-like planets in our galaxy. 20 million Earth-like planets. Okay. And that's even if there's only 1 in 10,000 stars has an Earth. So that's a lot of Earth-like planets. Okay, now, the next thing that he says, okay, well, what fraction of those Earth-like planets will get life? And what he said was, all will get life. So his opinion, remember, this is just one of your fellow students, okay, not, this is offering his opinion, okay? All of them will get life. Well, that means that we then have 20 million life-having planets. All right, so there's 20 million planets out there that are going to get life at some point in their history. Okay, now, advanced technological life. Okay, life includes, bacteria. Bacteria is life, okay? Plants are life. So we want technologically advanced life that we could communicate with. In other words, makes radio transmitters. Okay, now, on the Reese criterion again, he was pessimistic on this. He said, technologically advanced, 1 in 10 million. 1 in 10 million, that was his guess. That life would be, reasonable, but technologically advanced life, in his estimation, really, really low. Okay, well then, how do you work that out? Well, you take, that's 1 in 10 million times 20 million. So 1 in 10 million times 20 million is equal to 2. Okay. 2. So there will be 2 planets out there in our galaxy that at some point will get technologically advanced life, radio transmission. But that's at some point, okay? That doesn't mean that they exist now. They could have existed. There's 2, and the 2 planets out there, but maybe one of them has already had that civilization rise and fall 500,000 years ago. And maybe the next one, the other one, its civilization won't rise for another 20,000 years. So like right now, there may be nothing, okay? In fact, there's going to be nothing. Because the other thing was, how long will they last? And he said, not long. Okay, that was his estimation. Not long. In other words, it won't be long when you get a technologically advanced civilization. It would not be long until something bad happens. So I'm going to pick 500 years. Okay. That's actually, that's a lot longer than we've lasted so far. Okay, but it's not very long. So, now, how long is a planet habitable? Well, it turns out, the Earth, we think, formed 5 billion years in the past, and it will probably last another 5 billion years. So, that's like 10 billion years. And so, maybe half of that period could have intelligent life on it or something like that. So, say 5 billion years of life. So, if we have 500 years that a civilization lasts over 5 billion years of possible habitability, then our chance of catching that planet with people on it would be, cancel those, and that becomes 1. That is 1 in 1, 2, 3, 4, 5, 6, 7. 1 in 10 million. So you take 1 in 10 million times 2. That's 2 in 10 million. So you end up with the number of civilizations that would be in our galaxy is 2 divided by 10 million in our galaxy, based on the Reese criteria. 2 in 10 million. That means that there's nothing in our galaxy except us, okay, based on what your fellow student had pulled up. Not only that, but you would have to look at 10 million other galaxies before you would find 2 other ones right now. So that not only based on this on Reese's numbers, not only is there nothing in our galaxy, but there's nothing in the overwhelming majority of other galaxies in the universe, such that you only have maybe 2 other civilizations for every 10 million galaxies out there. Now, we think there's billions of galaxies, hundreds of billions of galaxies. So in the universe, even that low number still comes out to a fair number of civilizations somewhere, but they're so widely separated, you will never, ever, ever, ever find them. Okay, there's no, so in this setup, we're effectively alone, okay, if this is correct. So this is how you do a Drake equation calculation. You look at, like, what do you think are reasonable and numbers, and run them through and see, well, what does that mean? And in this particular case, we've got that, well, the universe is full of life-having planets, oodles and oodles of life-having planets, but there are no technologically advanced civilizations to speak of that we will ever detect. Okay, there may be quite a few over the overall lifespan of the universe, but nothing that we're ever going to run into. So we're effectively alone.